Hello, welcome back to another session. Today we're going to talk about linked lists in data structures and algorithms. And without further ado, let us begin. Okay, so data structures and algorithms. In our previous tutorial, we talked about um, algorithm analysis, right? And I'm pretty sure I'll post some videos or some content, some practice content that help you to study, help you to practice answering algorithms. But for now, what I want to focus on is essentially linked lists when it comes to data structures and algorithms. And as the course suggests itself, that these are data structures and algorithms. So here we're talking about these structures that exist within the system, right? So one of those structures are linked lists. Okay, so a linked list is not an algorithm. Okay, it can be implemented using an algorithm, but it's not particularly an algorithm, it's data structure. Okay, so I don't want to confuse you. Let's begin. So linked lists, linear data structures where elements called nodes, this is a very important ketone, nodes are connected by pointers. Unlike arrays, linked lists do not require contiguous memory allocation and allow dynamic memory allocation. Okay, so let me just break down what this means. So a linked list is a linear data structure where elements called nodes are connected by pointers. So this closely ties with programming languages and paradigms. So there's a lot of similarities between these concepts. So in programming languages and paradigms, you learn that there is memory within your system. Even in a computer architecture course, you learned about memory within a system. And that memory, right, has things allocated to it. So now a linked list is a data structure where elements called nodes are connected by pointers. And pointers essentially are things that point to memory or to a storage in memory. Okay, so this is kind of like, let's just say we've got a point here, right? This is our program in code, and then this is our memory bus. Okay, so in a nutshell, what we have is that this element in our array points to a point in memory here. Okay, so something allocates this particular section to memory, and what that is a pointer. So a pointer points things. Let's just say elements, variables, anything into a point in memory, right? So it allocates something in a point in memory. What that thing is called a pointer. Okay. So now a linked list is a linear data structure where elements called nodes, right? So imagine this guy is a node there, right? Connected by pointers. So we've got this point here pointing to the next node, or pointing to a point in memory. So this guy is just called a pointer. Okay, so that's a little something in programming languages and paradigms. So a linked list is a linear data structure where elements called nodes are connected by pointers, unlike arrays. So unlike arrays, linked lists do not require contiguous memory allocation. So what this means, right, go back to memory, programming languages and paradigms, is that an array, okay, is something that is fixed, okay? It's something that is fixed. So when you declare an array, right, you have a fixed bus. Let's just say you've got a fixed kind of bus here, okay, that contains all these slots. So an array here, you can put one element in an array. If you were to run an array in Java program, you're going to say that we've got array here, one, and then all these slots are not empty when it comes to an array, right? All these slots are not empty because they have a value to them because they are stored in memory. I don't know if I'm making sense. So let me just buckle down and then just explain this again. So an array, right, when you declare it in your program, what happens is that it acts like a bus where the size of that array, because when you declare an array, I'm sure you put in the size, for example, let's for the size of 5, right? An array with the size of 5 has got 5 slots in it, and they are not empty. That's the thing. Okay, so when you declare something when you declare an array to have a space of 5, the Java program or your programming language or the compiler is going to get that information and it's going to allocate 5 spaces in memory. Okay, so we see that even if you just put one element in an array, the rest of the elements are going to be zeros, because these have been fixed within memory. So if you access the point here at this point, you get the value 0. But then you think to yourself, but I haven't put anything, right? 0 should not even be there. Okay, but the thing is, with an array, you declare it statically. I don't know if that makes sense. It's statically put there. Okay, so it has contiguous memory allocation. Okay, meaning that what you do is that you get that information, you get an array, and then when you declare it to say that it's got a space of 5, and even if you just put one element in your array, these elements are automatically filled by a number 0. Okay, so now there's a difference between an array and a linked list, because a linked list, you can say you have a node there, you have another node there, and you have another node there. Okay, the space of this data structure and the space of this data structure, let me just put this, let me just put that there, 5. So the space of this data structure, which is a linked list, right, which has got node 1, node 2, node 3, node 4, node 5, and then you've got an array which has got array element 1, 2, 3, 4, and 5. So the difference between these two is that, yeah, they occupy the same memory space, but if I say that here, let me just remove this guy here. Okay, so if I say that I put 1 here and another 1 here, this memory is equal to 5, right? And if I remove this guy here, I just remove the element, okay, it will still remain 5. However, for a linked list, right, if I remove the element like I did there, it was initially 5. If I remove the element, it's going to be equal to 4. If I remove another element, it's going to be equal to 3. If I remove another element, it's going to be 2. And then if I remove that there, it's going to be 1. Okay? So that's the difference between an array and a linked list. A linked list basically has dynamic memory allocation, meaning that it's not static. Meaning as well that if I was to add another node, the allocated space in memory is going to be 2, right? From 1 to 2 there. If I add another one, it's going to be 3. If I add another one, it's going to be 4. Okay? If I was to remove 1, like I have done here, it's going to be 3. Right? If I remove another one, it's going to be 2, and so on and so forth. Okay? So this guy here, regardless of if I remove all of these here, the memory allocation will still remain 5. That's the key takeaway between these videos. The memory allocation for an array is going to still remain 5, but for a linked list, if I remove nodes from there, the memory allocation is going to reduce. Okay? So from this explanation, you see that 1, linked lists have got better memory allocation and efficiency compared to arrays. Okay. Number 2, the difference between an array and a linked list is that an array has got fixed memory, whereas a linked list has got dynamic memory. Hope that makes any type of sense there. Okay. Cool. So when we go to the types of linked lists now, we've got singly linked lists, where each node has reference to the next node. For example, like this node here references or points to this node here. So this is called a head node, And the last one within the list here is called a tail node. Okay, so we've got the head node there, and then we've got this guy here, and then we've got the tail node there. Okay, so each node has reference to the next node, and each node has got a memory space allocated to it. So you've got space 1, space 2, space 3 there. So this is a singly linked list, right? Meaning it's going in one direction. Okay, a doubly linked list, however, has this type of orientation. So we've got our head node there, and then we have pointing the next node there, like that. Pointing also to the next node there. This is our tail, right? A doubly linked list is going to reference this guy backwards, like that. Actually, no. Yes. Yeah, sorry. I almost mixed it up. So, a doubly linked list, each node has references to both the next and the previous node. So, unless if it's the head or the tail is referencing the previous one, but then this middle node here is referencing both the next node there and the previous node. So it knows the node that is before it, that came before it, and the node that is coming after it. Okay, so that's a doubly linked list. And then a circular linked list, the last node points back to the first node, which forms a loop. So we've got some kind of orientation like this. Our head node there, we've got that node there, and then we have that node there, our tail node. So we have this orientation, but then a circular linked list, the last node here references the first node, which creates a loop. Okay, so I hope that explanation just helps you understand the types of linked lists. Yeah, so let's get into greater detail of what these are. Okay. Okay. One moment, please. One moment, please. Sorry, I'm just checking something. Okay, sorry for that. So singly linked list, right? We already looked at the definition. Okay, so a singly linked list consists of nodes where each node contains the data that it carries, okay, and the next value, which is a pointer to the next node in the sequence. So going deeper into how a singly linked list looks like, we have this guy here. This is what a node looks like, okay, in essence. So we have two functions here. We have the data aspect, and then we have the pointer there. So we've got the data and we've got the pointer, right? And if we have another node here with two sections, and another node here with two sections, we see that this pointer references this data here, right? And then here, because this is our pointer, this references this data. So we see here that we've got the data, which is stored in the node, right? And then the pointer to the next node in the sequence. So this pointer references this data, right? And then this pointer references this data, and so on and so forth. I hope that makes sense. So now, this is how you write that in pseudocode, right? Let me just move that there. So, operations on singly linked lists include inserting a node at the start, where you've got function insert front there. So you've got the head, and then you've got the value, okay? So we declare a new node equals to create node, which is going to be the value there, takes in that value. New node.next is equals to the head there. So what we're saying here is that we've got new node, okay? This is going to be our data, okay? New node, and then new node.next references our head, okay? So we're just telling that this data belongs to this head. Then head is going to be equal to new node, which is this guy here, and then return head. So what we are doing is this. We are inserting a new head within the linked list. How are we doing that? We are saying that new node, create node their value. Okay. The next value here. So, okay, new node, create node, right? So I've created a node like that. New node dot next, meaning the next value here is going to be equal to the head. Okay. So the next value is going to be the head. Then head is going to equal to new node, which is this guy here. I don't know if that's making any sense. Let me try to explain it in a proper way. This code is saying that new node is equals to create node. Okay, so we've created a new node, which is this guy. Okay, let me start from scratch here. This might be confusing, so just stay with me. Okay, so new node here, we're creating a new node. We're assuming that there's already a list. Okay, so we already have a list here, new node, and then we've created a new node there. Okay, so this is the initial node, which is the head, and we've got a new node, which is the guy we've created. So new node dot next, right? So the new node dot next contains the head value. So this guy is going to contain the data from the head, right? Then head is equals to new node. So meaning head here, this guy is going to be equal to new node. Sorry for the background noise. Let me just try to do this. Okay. So new node dot next is equals to head, right? So meaning the next reference here is going to contain data from the head. Pay attention now, okay? Then the head itself, okay? The head value, because now we've inserted the head data, the head value is going to be this guy. It's going to be equal to the new node. So this is going to be the new head, and then it's going to be the node, okay? Then we return the head. So I know this is confusing. This is confusing. It's even confusing me as well, so just bear with me, okay? Let's use numbers, okay? What we're saying is that we created a new node with a value of 1, right? And then new node dot next, meaning that the next value of the head here, new node dot head, the next is going to contain the data in the head. Yeah, data structures and algorithms is a little bit tricky because I'm even confusing myself. So let's start all over again. Yeah. So let's create a new node. Okay, like that. Here we've created a new node and we've labeled it as new node. Then new node dot next, right? So new node dot next, meaning we create another node which is going to contain the contents of the heads, right? So meaning that the new node dot next contains the head. Then now, because we've created a new node, the first in the list here is going to be our new head. Okay? Or if we were to say that, new head here, new. Okay, yeah. So new head is equals to new node. Okay? So the new head, which is this guy, references now the value of the new node now. So meaning this is going to be our new variable, like that. And then we return the new head here, like that. Yeah, this is a little bit tricky, but that's the whole idea behind it, right? So first we create a new node, which is this guy, okay? So we have our head, okay? Then we create a new node, which is this guy, okay? Then new node dot next, which is uyu mugaye is uyu, is going to contain the data of the previous heads, okay, which is this variable here. Then our new head is going to contain, this is our new head, right? It's going to contain the data of our new value, which is new node there, value. So it's going to contain the value of that guy. And then what's going to happen now is we're trying to return the new head now. So meaning that we've inserted a node at the beginning of the array, or the beginning of the linked list. So maybe this was a little bit confusing because we had to do a lot of iterations and a lot of takes. And I'm assuming that a lot of you want to understand this, but if you did, congratulations. But if you didn't, I'll try to explain this one last time. I think I've spent a lot of time here, but I'll try to explain this one last time so that you get the hang of it, okay? So, we have our head there, right? Let's just do this here. We have our linked list like that. We have our linked list, right? So now, new node creates node value, right? Good. So we are creating a node here. Let's just say, nah, 3 of them is not enough. So let me just use 2. Okay, just ignore this. Sorry. Ignore this. Ignore this. Ignore this. Ignore this. We have our new head there. We have our head, right? Then we're saying that we create a new node there with a value. So we've created a new node there. Okay. Now remember that a linked list always has a head and a tail, right? So if we are trying to insert a new node, we're going to say that we've created this guy here. Then new node dot next, meaning that the next guy here should contain the data that was in the previous head. So this guy is going to contain the previous head's data, right? Then now, because a linked list always has a head and a tail, this new head variable here is going to equal to new node. So remember, this is our new node, right? So the data in the new head or in the new node is going to contain, the data in the new head is going to contain the value that we got there, because new node is equal to value there, right? So it's going to contain our new value like that there, okay? And then we return the head. So basically what we're doing is that we are creating a new node, and we're saying that all the data that was in the head here should transfer to this head, right? And if it transfers to this head, then, if it transfers to this node, means that this data here is going to be empty, right? Then we say that after we've transferred the data to this guy here, we update this node to contain the new value. Maybe that makes more sense now, right? Because this implementation here might be confusing and whatnot, but we are saying that create a new node, transfer the data that was in the head into the new node, right? And then here in the space that is left, put the new value like that. So this is the pseudocode for that, basically. Okay? That is the simplest way I can explain. Yeah. So it's the same as inserting at the end, where we have a list there, right? All pointing to each other like that. Then we create a new node like that. Initially it's empty, it's now, right? So if head is now, meaning that it's the first element, right? Or it's not referencing anything, head is equals to new node. Okay? So if the head is now, okay, meaning that new node is going to contain head. So let me just use simple demographics there. Let me just destroy that. Okay, let me start like that. So if the head is now, okay, meaning it's got no data referencing to it, then we create a new node right? And then we return the head value, meaning this guy here. So meaning we've inserted a new node at the end, essentially, right? And then we put the head in a temporary array somewhere where we can keep it. And then while the head here, the next is not now. So meaning if we don't have anything referencing the tail, right? Or if so while temp.next is not now, meaning that whilst the head there .next is not empty or it's not referencing anything, we traverse this list. So we find the last element. So this finds the last element here. This while loop finds the last element. Okay? So it's going to stop when it reaches Oyumgaizu, because we say that this is the last one. So temp.next, it moves 1, 2, like that. Then end while there. Okay, so we've reached the last element. So we've traversed this list. And then now we say temp.next is equal to new node. So meaning we've created a new node now at the end there, and then we return the head variable there, like that, end function. I think this one was easier to explain than the first one. Yeah. So let me just reiterate myself, right? If the head is not now, meaning the list is empty, right? Oh, if the head is now, sorry, right? Meaning the list is empty. Yes. Meaning that the list is empty. Then head becomes the new node, and we've created a linked list. What this means is that if we don't have an array, right? Or if we don't have a linked list, meaning it's now, if we've got nothing pointing to anywhere, right? Then we say that the head becomes the new node, meaning we've created something at the end and we have something in our linked list. We return the head, right? But then we put the head in a temporary folder or in a temporary file, and then we say, while temp.next is not now, right? So if we have more than one element in our linked list, right? Like we did here, then traverse this linked list until we find the last element. So while temp.next is not now, do temp is equals to temp.next. So we're moving to this point. We check, is the next one now? No. Okay, we move to the next one. Is the next one now? Yes, it is. So we are here now, right? We end well. Temp.next is equal to new node. Okay, so we're inserting at the end. So because this guy has got a now value at the end, we are going to create a new node and reference it like that, and then we return the head variable and function. I think this one was easier to explain than linked lists. So it looks like this, right? So insert a node in between. It's the same concept here, right? So you've got insert middle, you've got the head, the value, and the position. So new node, we create the node new value, and then temp is equal to head. So for I from 1 to position -1, do temp next. Okay. So what this does is that for I from 1 to position -1, okay, do temp, which is the head, is equals to temp.next. So we're traversing through the list there, right? New node.next. Okay, so we're saying that our new node, we go to the next one, is going to equals to temp.next there. So same thing that we were doing in the previous one. And then we're going to say that temp.next is equals to new node. So it's the same type of principle. I highly suggest that you write some Java programs so that you better understand what you're doing. Okay. What else are we talking about here? I know this concept is a little bit tricky, right? And I'll give you some other pointers later on, but it's important for you to understand the operations that are happening in the operations there. So basically what we're saying is that we have this list, right? Which is referencing that list there and that list there. Okay. So what we need to do is what this is basically saying is that we've got our head, right? And we're traversing through this list here from 1 to position -1. So position is where we want to place our linked list, right? So let's just say we want to place our linked list there, okay? Or we want to insert our node there. What we're doing is from 1 to position -1, meaning the previous one here, right? So from 1 here to position -1, which is within this space, okay? We put that temp variable there, that next position here, into a temporary array. So we remove this temporarily, right? Then new node.next, okay? New node, because we've created a new node. So the next value is going to contain the node that we had here. So it's going to reference this guy instead. It's going to point to this guy, okay? And then temp.next is going to reference this new node here. And then this node is going to continue referencing that. So essentially, that's what it's talking about, right? Again, I know this is a tricky concept, but in hindsight, this is how it works. So what we do is that if we want to insert something, we get this value, we put it in a temporary array, then we get this head and reference it to our new variable. Then we get this guy here, our new node, and reference it to our temporary node there, something like that there. Then deleting is just the opposite of that. This pseudocode is a little bit tricky, so I highly advise that you do a little bit more research on pseudocode when it comes to single linked lists. Yeah. Okay. So double linked list consists of nodes where each node contains data, the next and the previous pointer, right? So we've got our head there, our data, and then we've got our previous pointer there. So we've got a previous and we've got our next. We've got our previous, we've got our next, and just like that, and so on and so forth. And inserting the function here, we have all these. Let me just move this guy here. We can just do that. Yeah. Okay. So operations on doubly linked list here, we've got inserting node at the front, inserting node at the end there. Yeah. So essentially, this is what it looks like, right? So towards the end of a tail, so the tail here, right? A tail always references a noun, right? Always references a noun. So that's how you know if a linked list has got a tail or not. So the final part here references a noun value. So that's how you know that it's the tail, right? So if it doesn't reference the guy there, then that's that. What else? Yeah. So essentially, a doubly linked list has its head pointing to a null value, and has its tail also pointing to a null value, like that there. And then here in between, each one is referencing the next or the friend and whatnot. So here, insert front head, new node is equals to create node. So here we create a new node, right? The new node next is equals to the head, okay? So now, if the head is not now, meaning that we don't have an empty list, then head.previous is going to be equal to new node. So meaning, all we're saying is, here we've got the node, right? And if the head is not now, then the previous guy, head.previous, is going to reference this guy here. So we've referenced that. Head.previous is equal to new node. Then new node.next is equal to head, like that. Yeah. New node.next is going to that. Then the head, the previous is going to equals to that. Yeah, so something like that. So there's a homogeneous type of relationship there, right? So inserting at the end, here it's saying that you create a new node. So you've got a head there, you insert a new node. So if head is now, then head is equal to the new node, then return head, right? Then we put the head in a temporary array. Then while temp.next is not now. So while the temporary, meaning while the head.next is not now, you traverse this list, and then temp.next is going to be equal to the new node. Let's just say this guy here, and then the new node, the previous, references that guy. This pseudocode is a little bit complicated, so what I'm going to do is I'm going to provide Java code so that you understand properly what's happening here, because this pseudocode from my sources, it's correct, but it's not as simplified as it was. So what I'm going to do is I'm going to provide more context on the pseudocode that is going to be used here, and also some Java code so that you properly understand what's happening. Okay, yeah. So inserting a node at the end, inserting a node at the beginning, and whatnot and everything. Then circular linked lists is the same here. We see that we've got our data there, it references the next. Or single linked list here, we've got our data referencing the next, and the next, and the next. Where circular linked list now, you say that the head references the next value references the next, and the next, but then the tail references the head and then creates a loop like that there. So you have that data, and then you have that. So like I mentioned, I'm going to give proper documentation and also proper code, pseudocode for you to actually practice and whatnot. Okay, but in summary, a linked list is a linear data structure where elements, which are nodes, are connected by pointers rather than stored in contiguous memory allocations. Each node contains data and a reference pointer, or reference, which is also known as pointer, to the next node. So the types of linked lists are single linked lists, where each node points to the next node, forming a one-way chain. Doubly linked lists, where each node points to the next and the previous nodes, allowing traversal in both directions. And then a circular linked list is the last node connects back to the first node, which forms a loop. All right. I think that's all. Thank you so much for tuning in. And I know this doesn't really make any sense currently, but I am going to provide more context on everything. Otherwise, thank you so much and take care.